popping into existence. So generally, you might want to use a smaller offset on that value, but it's basically a way of further randomizing the animation as it plays back. So we'll just stop that there. So as I said, the maximum offset, as far as I understand it, is a positive offset. You can't really start the bitmap sequence on a negative frame. That wouldn't work very well. So obviously it can on the point that the particle enters into the event and gets assigned its dynamic material, it can be assigned one of those bitmap frames anywhere from frame 0 to frame 21, and it's just random, so obviously that can cause issues, as you saw just now, where if you wanted the particles to fade in, that's not going to happen if you've got an offset which actually offsets into the animated part of the bitmap where it's very bright. And if that's the case, your particles are going to pop into existence with a bright texture. So you've got to be careful with that. So let's have a look at the next set of options, which is the submaterial rotoscoping. And for that, I'll go back down to the material dynamic operator, which has the multi-sub-object texture material applied. And these options allow greater control of the assignment of material IDs to your particles when you're working with multi-sub-object materials. In this case, the assignment is dynamic. In other words, it can change from frame to frame, whereas as we saw in the material static operator, it's fixed. It can obviously change the IDs as the particles enter the event, but that's it. Once the IDs are assigned, they just stay the same. So let's have a look at the options. Let's quickly run through them. With material ID, you can basically just choose a fixed material ID, and this is actually applied as the particle enters the event. You also need to note that with this option, the material ID is not updated from frame to frame. So in other words, it's static. If we go on to the next option, which is cycle, with this option, each particle is assigned a material ID in order, up to the maximum defined by the submaterials parameter. So you can see you've got 7 here. This is pretty much the same as in material static. The first particle is assigned ID 1, the second particle is assigned ID 2, and so on. This can be further controlled via the rate per second parameter, which you've got here. And you've also got a loop parameter again, so we can loop back through the IDs when we reach the end, or we can just use the last value chosen. The other option we have is to use a random assignment where each particle is assigned a random material ID value within the range defined by the submaterial parameter here. For instance, if this is set to 8, then the particles can be any ID from 1 to 8. And you can see that in our case here, we've got it set to 7. And it'll just obviously pick any material ID between 1 and 7 and just assign those randomly. Then we have the rate per sec parameter, and this option allows you to define how often the material ID is incremented when it's assigned in an animated sequence. And this is very similar to the same parameter in the previous operator. Now, if this number matches your frame rate, you will get a 1 increment in IDs per frame. And any other values will work in a similar manner depending on the proportion between your frame rate and the value that you've used. So again, if you had NTSC and you've got a rate of 30 and you use a value of 30, that means that you'll get 1 increment per frame. If you're using NTSC and you use a value of 15, that will mean that you'll get 1 increment every 2 frames, and so on. With a value of 90, you'd get an increment of 3 IDs per frame, and so forth. So you've just got to work out the ratio between the rate per sec value and your current frame rate to actually work out what you're going to get with those things. If I go back to the first frame, you can see that's animating. So we'll find out how that's happening by looking at the next set of parameters. Now, what's actually happening here is from frame to frame, if we actually scrub through